So performance testing, there is some results. We have tons of different tests that we run for different platforms. For Windows, SQLStress. We have very large customer with tons of database. It's a service provider, and this is with us, without us. So we guarantee 40, 50,000 IOPS constantly, and you see the huge difference. It was with Virident card specifically. SQLStress, it's standard benchmark. Next, please. You'll see the difference as usually. TPC-C, we run like TPC-C test. We actually use benchmark factory, and we use TPC-C-like test. And you can see the huge advantages in the write back. This is a JBot. If you have very powerful storage, of course, write through will be close to write back. But one of very important advantages of write back, some of our very large customers, they have, let's say, RAID 5 shared storage box and multiple servers. They have LANs from this storage. And because in the moment we flush, we coalesce data, it's very good for RAID 5 configuration. So real data, I can give you real data without name. One of our customer, very big customer, very huge customer, the reduction in number of writes, it is Oracle online transaction. In times of writes, 25 times less number of writes we start. And we flush only 30% of entire data set after write cancellation. When we rewrite the same data again and again, we only write the latest copy when we flush. So it's a huge reduction and improvement in the usage shared storage, which is important for our customers. I would say this is very important, I would say, especially for RAID 5, RAID 6 configurations.
So what kind of way, do you use any methods to determine the traffic, the degree to which the target data store is being used before you start flushing cache to it? Is there any feedback that you get from vCenter or anything like that?
We don't use this feedback, but we have our own statistics, and we have our own tool that I'll talk in part 2 that we can use to tune parameters and predict performance advantages.
Okay.
We'll talk about this. In this moment, just run with default, check statistics, tune parameters, and after that, you can just pick right way for VMDK that you accelerate, or set of VMDKs. Next, please. Okay, this is Oracle benchmark factory, and just it's really high-end enterprise configuration. Very good server, a lot of hard drives, 48 hard drives, 15K. Next, please. In this test, we use actually 2 client drives, SAS, and Duo Fusion card. This is a Fusion. This is SAS. The difference, and the company that ran this evaluation, they were a little bit surprised. If you go next, please. This is a SLA level without acceleration. Just 1,500 users can support it. With acceleration, after tuning our parameters, it's 6,000 warehouses users can run. And as you can see, this is a Fusion part. As you can see that SAS is very close to Fusion. And guess what? Because even with SAS, we remove I/O as a bottleneck. And we almost, starting from somewhere here, we almost maximize CPU utilization. This is our goal. Because without us, CPU utilization is 10 to 20%. With us, it's 70, 80%. This is a goal. Remove bottleneck from the storage.
I think that's a very important point that, you know, our friends this morning have tried to convince the world that there's a 10 times performance difference between SAS SSDs and PCIe SSDs.
No, it should be balanced.
And you know, here we see, you know, there's a 20% difference from 5,000 to 6,000.
Yeah.
And so, you know, when you start going, well, I could get the $2,000 Intel DCS 3700, or I could get the $10,000 Fusion IO card. You know,
Right.
ask yourselves if that 20% is worth the 5 times cost difference.
System must be balanced. And by the way, this is enterprise system. Nothing against PCIe. For VMware, definitely. Sometimes we prefer PCIe because it's, yes, latency is less. And some of our very large customers, they use PCIe. High-end, actually, 3 high-end, 4 high-end. Okay, but you're absolutely right. For balance, must be balanced. Next, please. Okay, we run SpecVirt. For us, it took just 2 months to be able to set it up. And we triple, actually, VM density in a reasonable configuration. Next, please. We run also inside Windows guest 1 VM, 2 VMs, 4 VMs, running TPC-C inside. This is write-through mode, having acceleration in a ESX kernel. And it's interesting that for one VM, we are 2.5 times better. For 2 VMs, we're already 4 times better than baseline without us. So the more VM you add, of course, not 1,000, but in a reasonable range, the more VMs you add, the better we are in terms of performance. By the way, again, just to highlight that there is no necessity to increase the amount of resources, memory that we use or whatever. It is exactly the same. Same 140 megabytes, same 3–4% of CPU. Next, please. Okay. I hate to read.
That is a horrible slide.
Sorry.
We're good. We're good. We're good.
It's a summary of everything you said.
Let's just say whatever he said.
What Sergey said.
Okay. So thank you very much. I'm happy to answer your questions, maybe about some details. Always save time for part 2.
I missed replication and clustering part, but is that in the second half?
Yes.
Okay.
You don't miss.
So the currently shipping product for VMware is write-through only.
Yes.
Yes, so actually write through in a cluster, write back, single node. And we'll talk about this in more details. Thank you very much.
So Sergey, what you didn't talk about was whether you do anything about cache warming or in a vMotion environment, or you know what the result in terms of performance of vMotion is.
Yeah. Let me tell about our position here. First of all, vMotion is not a routine. It's kind of exception. And
unless you use DRS heavily.
But lots of our customers, they turn off DRS, and they have their own policy. And you know, not worse than me, that vMotion is not for free. And especially if the rate of exchanging memory is high, it takes time. vMotion takes time. So if you can run VM here, you run VM here. In this moment, for one server, we have access history. And if you turn on and off virtual machine, we still have this history for specific VMDK. If you restart VM on the same node, cache is warm, and we continue this. In case of vMotion, in a product that we ship, we start from cold cache. However, it is possible to, as a part of vMotion, to share our access history to the node where we have it, VM started, because we see the open request, and use this information to rewarm cache as soon as possible. But in write-through mode, nodes, our drivers running on different nodes, they do not talk. We're absolutely transparent in this point. So in order to do what I described, we have to intercept close, potential close as a part of vMotion, as a part of close to transfer this access history over there, and for the product that we have, and for frequency of using vMotion, I would say, we decided not to do it in this moment. Nothing against starting with warm cache, but again, cache will be warm if you restart VM on the same machine. And if you think about rewarming cache, or it is runtime replication, and we'll talk about it in part 2, or it is a part of vMotion, and we do not want to expand time for vMotion. So in this case, you will start with cold cache.